Okay, so this is objective 33. We've already started through this yesterday. We're going to solve systems by elimination. We know that when we're looking at a system, we're looking at two or more equations at the same time. Okay. Um, ooh, it actually stopped on it. We know that if it's one solution, that it will be two lines that intersect at one point. Okay. So you will have a line like so and a line like so. So your intersection, you're looking for an X and a Y. You know that if it is no solution, that the two lines will be parallel. And what do you know about parallel lines? They never intersect, and what do you know about their equations? They have the same slope. If you're solving it algebraically, which we do when we solve using substitution or elimination, what happens for it to be no solution? The variables end up canceling, and you get two things that are not equal. You get a false statement. So that would tell you that it would be no solution. With many solutions, graphically, they look like they are straight on top of each other. What do their equations look like? They're the same. If you and they may look different. You might have one in standard form and one in slope-intercept form. But when you rearrange them to the same form, it's going to be the same equation. Okay, the same exact equation. Algebraically, if you solved it, if both variables cancel, you end up with two things that are equal. Okay, like 5 is equal to 5. Two things that are the same. So that's what it would look like algebraically. Okay, I feel like the more times I say this, the more times you will remember it. So I'm not going to work through all of these, but I'm going to tell you there's 4 different types of elimination problems. Okay, the first type is if you already have opposites. This is the easy way. You don't have to do anything, correct? Except add them. So what we do is we add our equations together. My y's will cancel, and I get 8x equals 16 when I add negative 32 and 48. And then because you have eliminated one of the variables, you can then solve for the other. And so x would come out to equal 2. How would we figure out y? You take it and you plug it back in for the x either in door number 1 or door number 2, and there you go. Okay, any questions on that? So just to show you really quickly, if I plugged it back in, I'm going to use the second one. 3 times 2 plus 6y equals 48. So 6 plus 6y. And someone asked yesterday, can we stick all of this in our calculator? And you can use the calculator to help you add, subtract, multiply, or divide, but you can't just stick the whole thing in your calculator because you actually have to do some rearranging and solving. So 6y equals 42. So when you divide by 6, y would equal 7. So the point would be 2 comma 7. Okay, so that's the first type that we looked at yesterday. You already have opposites. All you got to do is add your equations together and eliminate one of the variables. Any questions? So we went on through example 3. Then we got to example 4 and 5. I'll take a look at 5 if I can get there. Okay. The second type is you don't have opposites, but all you need to do is change all the signs in one of the equations. So I would pick the top one. So if we change the 12x to a positive 12x, if we change the negative 6y to a positive 6y, then you then have opposites. And then if you change your negative 42 to a positive 42, from there, those will cancel. That will give you 26x. Negative 16 and 42 gives you 26. So x would equal 1. Then you could figure out your y by plugging in. Okay, so any questions about that? No? Are you sure? So the first type, you already have opposites. You just add them together, go from there. The second type, all you need to do to make opposites is change all the signs in one of the equations. The third type is where we left off yesterday, is that you have to, and I'm going to actually work out example 8. Is that where we are? Have we done this one yet? You did this. This is the one you did, but I haven't done. Okay. The third type is where you don't have opposite numbers, but you can get opposite numbers by multiplying one of the equations. Okay? So just to check what you did, I'm going to multiply the bottom one by 3. And everybody says, why by 3, Miss Corns? Because if you look at your x's, can you multiply something by 3 to get 5 or 5 to get 3? No. So you don't use your x's. If you look at your y's, can I multiply something by -2 to get 6? Yes, and you can multiply it by 3. So that's why I chose that. So when I multiply this will give me -15x, -6y, and then that will give me -42. Now, which two equations am I working with at this point in time? I'm working with the top one and the bottom one. And do you remember my example of talking to Ethan yesterday when Kayla was in the middle? Okay, when you have something in the middle, it's going to confuse you because you can't get to what you need. I mean, you could, but chances are some of us might make a careless error. So the best thing to do is take our top one and rewrite it underneath. So that's what I'm going to do. Either you rearrange it in the beginning or you rearrange it after. Somewhere along the way, you got to get your two equations together, but yes. Okay? All right, so then you can go ahead and go for it. These will cancel. This should give me -12x. -42 and -6 gives me -48. And when I divide by -12, x is going to equal +4. Any questions about that? To figure out what x is, I can plug into door number 1, original door number 2, or new and improved, but the same thing as door number 2, but slightly bigger, door number 3. It don't matter. It really, well, the top one would be door number 1, the second one would be door number 2, and then the next one would be door number 3. So I'm going to get 12 plus 6y equals -6. When I move this over and subtract 12, I get 6y equals -18. When I divide by 6, y is going to equal -3. So the point is for -3. Any questions? Did we all get that? Yes? Okay, so that's the third type where you have to multiply one of the equations by something. So, skipping back, here is now the fourth type. What do you notice about this equation? There's nothing that I can times by 4 to get 7 or 7 to get 4. And there's nothing that I can times by 2 to get 3 or 3 to get 2. So Sydney says, and you would make, I don't know why I have to teach. Y'all do it yourselves. Okay, so you do not have to, you're going to times both of them. Okay, so here's the thing. You either need to make opposites with your x's or with your y's. So what could I make with 4 and 7? You could make 28, and so that means you times the 4 by 7 and the 7 by 4, and you would, one of them would be a negative. Okay, what can you make with 2 and 3? 6. So you would times the top by 3 and the bottom by 2. Would you have to make any of them a negative? No, because you already have opposite signs. So let me ask you this. Would you rather make 28 or would you rather make 6? 6. Okay, which is why, go away, go away. I don't want that. No idea what we're doing here, but okay. Let's get back to this. See if I can pop my recording up. It still went away. Okay. All right, so we're going to times the top by 3 and the bottom by 2. So in the top equation, I'm going to have 12x plus 6y equals 42. Any questions on what I did? The bottom, I'm going to times by 2. This is going to make 14x minus 6y. Aha! Why do I say aha in a silly little voice? Because now I have opposites, and that's your goal, okay? And then 2 times negative 8 is negative 16. Now you have 2 brand new equations that you can work with, okay? So those cancel. This will give you 26x equals 26, and x is going to equal 1, okay? How many doors do you have a choice of to plug into? 4. You can choose original door number 1. You can choose original door number 2. You can choose new and improved but bigger because you times it by 3, door number 3. Or you can choose new and improved but bigger because you times it by 2, door number 4. I don't know that I would ever choose the ones that you multiply, because we talked about this yesterday. Once you multiply, I mean, they're the same things as these, but they're bigger. Why would you choose the bigger ones? Wouldn't we want the smaller ones? So, we say door number 1. That's fine with me. Equals 14. So 4 plus 2y equals 14. So 2y equals 10. And when you divide by 2, y will equal 5. So your point's going to be 1, 5. Questions? That was pretty simple. Did everybody understand why I times by 3 and why I times by 2? Okay. So 2 more examples, then we'll be done. Okay. Now we got to think what you would times by. You can do either the x's or the y's. It does not matter. What could you make with 15 and 10? 30. Now think about this. Everybody says, I don't want to make 30 because 15 is big. But look, what would you times the top by? 2 and the bottom by 3. What could you times by? You could make 21 with 7 and 3. So you'd have to times by 7 on the top and 3 on the bottom. One of them is going to have to be a negative in order to create opposite signs. So do you want to times by 2 and 3, or do you want to times by 7 and 3? I'd rather times by 2 and 3. Most people choose the 21. How many were already automatically looking at 21 to begin with? Because that's just a common multiple, 3 and 7, and you say, oh, 21, 21. But I think this would be better to do by 2 and then by 3 down here. Now, one of them needs to be by, does it matter which one? No, but I hear y'all telling me negative 2, so that's fine. Okay, so this is going to make negative 30x. This is going to make negative 6y. And this is going to make negative 18. Why don't you work the 3 out and finish it out? See what you can get with it. So I have the point 1, negative 2. Do we agree? Do you see where you went wrong? Anybody else have any questions? Okay. Gotcha. Make sure you get it in the right variable. How does Sir feel this morning? Are you okay with what I did? How's Logan feel? Good? Kelly, you good? Helen's great. Okay, so the last one, I'm going to let you do this one on your own. All right, you try that one on your own. Okay, anyone want to share their answer, or at least part of it? What did Morgan get? Sure. Negative 5, 5. Hunter's shaking his head in agreement. So is Macy. It's a good sign. Brian says yes. Okay. Did everybody get negative 5, 5, or at least part of it, if you didn't finish it? How many made 15 with the x's? How many made 35 with the y's? Anybody make 35 with the y's? Okay. I'd say 15 with the x's is a little bit shorter because it's a little smaller maybe. Okay. Can I do 35 with the y's just to show you it doesn't matter? Is that okay? Just to be different. So if I'm gonna make 35, I'm gonna make times by 7, and if I'm gonna make 35 down here, I'm gonna times by 5. One of them needs to be by negative in order to make negative signs. So what would I make negative? Negative 5? That'd be fine. Are you okay? Okay. Huh? Negative 5. Okay. Just checking. 35. This is going to give me 70. This is going to give me negative 25x and negative 35 and negative 50. Okay, it still works. Those cancel. That's going to give me a negative 4x. This is going to give me 20. And when I divide by negative 4, x is negative 5. Then when I plug back in, I can choose 1, 2, 3, or 4. I'm going to go with door number 1 because it looks nice and small and fine by me. 3 times negative 5 plus 5y equals 10. So this is going to give me negative 15 plus 5y equals 10. When you move this over and add 15, 5y equals 25. And when I divide by 5, y is going to equal 5. So I do agree, negative 5, positive 5. Okay? Questions? Did everybody get that? Yes, no, maybe so? Ask now, forever hold your peace. Okay. So, we're going to get to classwork in just a minute. Let me find my recording. Do I have a recording somewhere?